so today we're going to go over what is called the empirical rule, also known as the 68, 95, 99 rule. I'm going to use the. So when we have a normal distribution, when we have a normal distribution of quantitative data, the empirical rule, or the 68, 99, or 95, 99 rule says, starting from the mean, 68% of the data, or of the area underneath the curve, will be within one standard deviation from that mean. So from here to here, within one standard deviation, we will have 68% of the area underneath the curve. If we go out one more standard deviation, then we will be within, or we will have 95% of the area underneath that curve. And then finally, if we go out 3 standard deviations, we'll have 99.7% of the area underneath that curve. Now, of course, this is an approximation. It is not exactly 68%, it's not exactly 95%, but it's a nice rule of thumb to use if we're ever in a hurry and we need to approximate some things. Now, the nice thing about this is we can break up, or based on this rule, we can break up each individual section and get a decent approximation. If we just look at the 68%, that means within each one of these sections, we have 34% and 34% of the area underneath the curve right there. If we go out to the 95%, excluding the 68 that's already in the middle, that means within each of these sections, we have about 13.5 and about 13.5 of the area in each of those sections. And lastly, if we're going to the 99.7%, well, that means that we have about 2.5 and 2.5% on either side, leaving about 0.15 and 0.15 on either side. Now, if you add all this up, it adds up to 100 points, or maybe 101, 100.5, 100.1. I'm not real sure. It's a slight overestimation. But again, this is an approximation. It's just a useful tool to do some quick math if we're ever in a hurry, right? So based on this then, if we look at an example, suppose scores on a test are normally distributed. The mean score is 80 and the standard deviation is 7. Draw a normal curve to represent the scenario. Okay, so that means right here at the mean, is 80. And then each standard deviation we go out will increase or decrease by 7. So we go up to 87, then we'll go up to 94, then we'll go up to 101, and then in the other direction, we'll have 73, 66, 59. All right, so what percent scored less than 87? Well, since 87 is right here on the first standard deviation, we can go very quickly and add up all the percentages from before. So just based on this graph, since this is the first standard deviation, we see that we're including, first of all, the first half of the data, all of this, plus this 34% here. So if this is half, this is 50%, 34%. 50 plus 34, 84%. So therefore, 84% scored less than an 87. What percent scored less than a 73? Well, again, 73 is on the first standard deviation, but it is to the left. So basically, we're just doing the inverse of what we had before. We have half of the area here, and this 34%, 100% minus that 84% we had earlier would be 16%. What percent scored more than 94? All right, so if we're thinking about the standard deviation rules from 94, that's on the second standard deviation. So based on the empirical rule, 95% of the scores would be between these two, which means 5% is left over on the outside. So therefore, 2.5% would be here, and 2.5% would be there. So the answer to our question, what percent scored more than 94? Well, it's this bit right here, 2.5%. And lastly, 2.5% scored less than what value? Well, based on the same rule we just talked about, 2.5% would score less than the second standard deviation, so scored less than a 66. And that, in essence, is the empirical rule, both in theory and in practice. I hope this was helpful.